Okay, just straight back just to our integration of our typical trig functions. It's just about remembering the rule. So in here, the antiderivative of cos 3x, okay, so is 1 on k sine. So you just got to remember that the derivative, the integral of cos is positive, okay? So we get 1 on 3 sine 3x plus some constant c. We know we can split them up. Sine 2x minus cos 4x. So we know that sine becomes cos and cos becomes sine, but it's just a case of getting the signs right, the correct negative or positivity of it. So 1 on k, k is 2, so we get a half cos 2x, but sine is a negative, so it becomes negative, minus 1 on k sine 4x, so the antiderivative of cos is positive sine, so the sign doesn't change, and we get that there. If we get some sort of expression in here, don't forget that that pi on 2, all it does is a translation of pi on 2 units to the right. It doesn't change any angles, it doesn't change any gradients, so it has no impact. So the antiderivative of cos 2x minus pi on 2 dx is simply given by 1 on k sine 2x minus pi on 2 plus some constant c. Okay, so sine becomes cos, cos becomes sine. You then just have to determine whether or not you're going to change the negativity of the expression. Evaluating our integrals, okay, it's exactly the same. You've just got to be careful with zero. Normally when we substitute zero into our integral, we get zero because we're thinking of 0 cubed and 0 squared. But obviously, with our trig functions, if I put cos of 0 in, I get 1. So you've just got to be aware of that. For example, let's work out the antiderivative. So 1 on k cos kx, and sine becomes negative cos between pi on 4 and 0. I could take that negative half out the front, and I might just do that. That way I don't have to multiply everything by negative a half all the time, which is equal to negative a half out the front of cos of 2 times pi on 4 minus cos of 2 times 0 on 4, which is minus a half of 2 times pi on 4 is pi on 2, so I get cos pi on 2 minus cos of 0, which is equal to negative a half times, well, cos of pi on 2 is 0 minus cos of 0, which is 1. So I get pi on 2 as an answer. Yeah. So just be careful with your angles, and again, integration. This is a great way for examiners to check to see if you know your exact values, just to give you a trig expression and work out that integral. All right, moving along. Antiderivative of. Now, in this case, the k value is a quarter. Yeah, so 1 on a quarter is 4. So negative 4 because it's a sine, cos x on 4, subtract, k value is a 2, a half, it becomes sine, and because it's the cos function, the sign doesn't change, so it's minus a half sine 2x between pi and 0, which is equal to negative 4 times cos of pi on 4 minus a half sine 2 pi, close all that off, subtract negative 4 times cos of 0 minus a half times sine of 0, which is equal to, what's cos of pi on 4, root 2 on 2, negative 4 times root 2 on 2 minus sine of 2 pi is 0. Subtract, cos of 0 is 1, so that's a negative 4, minus sine of 0 is 0. So I'm going to get negative 4 times root 2 on 2, which is negative 2 root 2 minus 4, which is equal to 4 plus 2 root 2. So what we'll do at the end is I'll put the calculator dumps of all of these just so we can check our answers. So given I'm going to do that, let's make it a little bit closer here. So I'm getting 4 minus 2 root 2. That way I put somewhere for the picture. Okay, same thing, integral of, now the derivative of, antiderivative of cos is positive sine, so I get sine. K value is 3, so I get 1/3 sine 3x plus pi on 6, evaluated between pi on 3 and 0. So it's 1/3 times sine of, put pi on 3 in there, so I get 3 times pi on 3, which is pi minus 1/3 times sine of, put 0 in, I get 3 times 0 is 0. Which is equal to 1/3. See how that 1/3 could have come out the front? Now, sine of pi plus pi on 6, think about quadrants. There's pi, plus pi on 6 is there, so sine is negative. Sine of pi on 6 is a half, so it's going to be negative a half minus 1/3 times sine of 0 plus pi on 6, which is up here, positive a half. So I get minus 1/6 minus 1/6, which is minus 2/6, which is minus 1/3. So let's check these on our CAS. You can see from the calculator shots that the first one there equal to 1/2. What have I done there, Tone? Oh, look at that. I hope someone picked that up. I don't know why I put the pi in there, boys. So obviously equal to 1/2, so careless mistake. Picked it up eventually. There's our 4 minus 2 root 2 for that one there. And then our minus 1/3 corresponds to that one there. Okay, so make sure you know how to use both. I can't stress enough our ability to work these out on our calculator. So just be aware of that. Okay, another little application, calculate the exact area of the region bounded by the curve. So as soon as we have to find an area, we're going to do a graph. I'll do the graph in here. Sine x on 2. So what's that? So that means the period is 2 pi over 1/2, which is equal to 4 pi. So if we sketch that graph, it's just the graph of the sine graph. So that's 4 pi, that's 2 pi, isn't it? So there's a couple of ways we can consider this one. We know 3 pi is there, pi is there, all right? So what we've actually got is, I've got half a section, plus another section. All three of those sections are the same size. All right. So I could, absolutely I could, do from 0 to 2 pi sine 1/2 x dx plus the integral from, instead of 2 pi to 3 pi, well, let's minus the integral from 2 pi to 3 pi of sine 1/2 x dx. Could definitely do that. But if I'm going to do this by hand, I think it's much nicer if I realise, well, there's 3 of one section, 3 times the integral from 0 to pi of sine 1/2 x dx. That's going to be the simplest way for me. Antiderivative 1 on k, so 1 on 1/2 is 2. Sine becomes negative cos, so it's a cos 1/2 x between pi and 0. which is equal to 3 times negative 2 cos of pi on 2 minus 2 cos 0, which is 3 times, well, cos of 90 degrees is 0. So we can see 3 times in bracket, negative 2 times that is just negative 2 times 0. It should be a minus in there. Minus, minus, negative 2 cos of 0, which is 1. Bit messy. So it's 3 times positive 2, which is equal to 6 units. Again, we might put a calculator dump in there to show it. I'll do that now, actually. I'll put a calculator dump in there to show. Okay, so just I guess a little twist on how we might be asked to use the integral to solve for any unknown values. I guess if we've got an integral that we need to try and solve, we go through the process exactly the same way. So anti-differentiate, so the antiderivative of 4x cubed is x to the 4 on 4, so the 4's cancel between k and 0. That's equal to, substitute k in, that's equal to, let's get rid of that, equal to k to the 4 minus, substitute 0, 0, and that has to equal 27. So clearly in this one, k to the 4 is equal to 27. Therefore, k is equal to, what's that? The 4th root, of 27, which is the 4th root of 3 cubed, which is 3 to the power of 3/4. Now, I guess interestingly here, if we sort of do a quick graph sketch of this, what have we got next cube graph? What we're looking at is, so what's 3 to the power of 3/4? So, geez, what is it? Small number, we'll say there. So that's that area there. Now, because my graph is symmetrical, that's going to be negative 3 to the 3/4 there. So the areas will be the same. So obviously I get a negative answer there. So if I actually put in from 0 to negative 3 to the 3/4, that's going to cancel out the negative. So it'll also give me the same area. Now, in reality, we don't often do that. Normally they'll tell us that k is greater than 0, but just something to be aware of. Let's go to B. B just says same thing, antiderivative. So we get the antiderivative of e to the half x, 1.5 is 2. So e to the 2e x on 2 between k and 0. Substitute k in. 2e to the k on 2 minus, substitute 0 in. And that's equal to 4. So 2e to the k on 2 minus 2 is equal to 4. Take the 2 over, divide by 2. So therefore we get e to the k on 2 is equal to that 4 plus 2 over 2. E to the k on 2 is equal to 3. Log base e. Log base e of 3 is equal to k on 2. Therefore, k is equal to 2 natural log 3. So again, same sorts of processes. Let's see how we go fitting this one in here. Anti-differentiate, the antiderivative of cos is positive sign, cos k, 1 on k, so we're going to end up with 1.5 positive sine 2x bound between pi and k. Substitute my endpoints in. 1/2, might leave the half out. Sine of 2 pi minus sine of 2k. And that has to equal negative root 3 on 4. Multiplied by 2 across. So I get in the brackets sine of 2 pi, which is 0, minus sine 2k, and that's equal to 2 root 3 on 4, which is root 3 on 2. So let's just make that a positive and that a negative. Oops, that was a negative, isn't it? So that should be now both positives. What does that leave us with? We've got to work out sine inverse of that. So 2k is equal to sine inverse of root 3 on 2. Let's rub out that line. What's that from? Which means then that 2k is equal to sine positive here and here. Sine inverse of root 3 on 2 is pi on 3. So we get pi on 3 and 2 pi on 3. Since we're only within 0 to pi on 2, that'll be enough, because if I now divide by k2, I'll get pi on 6 and 2 pi on 6, yeah? So k is equal to pi on 6 and pi on 3. So I guess the process is very similar, isn't it? Work out your integral, it introduces an unknown, and then we solve for that unknown. Let's put the calculator snapshot in there and see what we've got. Yep, so hopefully you can sort of see our answers up here. There's my k to the 3 on 4. There's that negative 3 to the 3 on 4, just from that little area there, which is a bit unique. K is natural log 2 of 3, pi on 6 to pi on 3. Don't forget, if you don't want to get a general solution, put your restrictions in. Okay, off you go.